In this section, we are going to see how to find antilogarithm of a particular number using antilogarithm table. Let us consider antilog of 0.5322. When we want to find antilogarithm of a particular number, we are not supposed to consider the digit we have before the decimal, and we have to consider only the digits we have after the decimal. What do we have to do with the digit we have before the decimal? That will be included in the calculation bit later, that is after getting value from the antilogarithm table. When we go to the antilogarithm table, we have to consider only the digits we have after the decimal, in this case 5322. Let's get value for the number 5322 in antilogarithm table. Okay, now we can move to the antilogarithm table. Okay, here we are going to look at value for the number 5322 in antilogarithm table. So it's very simple, that is we have to go to 53rd row second column and mean difference second column. Okay, first let's go to 53rd row. So this is 53rd row. Okay, now we have to take second column, that is here, and in mean difference also we have to take the second column, that is here. Okay, now let's mark the number. In 53rd row and second column we have 3404, and in mean difference the second column we have 2. We have value 2 corresponding to 53rd row. So 3404 and mean difference 2. Now we have to add them. Whenever we get a value from antilogarithm table, we have to take decimal point after the first digit. So this is a value 3406 we have received from antilogarithm table. So in this value we have to take decimal point after the first digit 3. So 3.406 is the value we have received for the number 5322. So not only for this particular value, for any value we get from antilogarithm table, we have to take decimal point after the first digit. Okay, so now we got the value 3.406 in the antilogarithm table for the number 5322. Okay, let's move to the previous page. Okay, we got value for 5322 in the antilogarithm table, that is 3.406. Whenever we get a value from antilogarithm table, it has to be multiplied by 10, and for this 10 the digit we have here before the decimal should be taken as exponent. Then we get 10 to the power of 0. So 3.406 times the value of 10 to the power of 0 is just 1, because anything to the power of 0 is equal to 1. So 3.406 times 1 is 3.406. So the antilog of 0.5322 is 3.406. Okay, let's look at the next example. Antilog of 2.5322. Okay, so in the previous example I told you very clearly, when we use the antilogarithm table, we are not supposed to consider the digit we have before the decimal. We have to consider only the digits after the decimal, that is 5322. Just now we got the value in antilogarithm table for 5322, that is 3.406. So the same can be taken here, and always the value we get from antilogarithm table to be multiplied by 10, and for this 10 the digit we have before the decimal should be taken as exponent. Here we have the digit 2 before the decimal point. This 2 should be taken as exponent of 10. So now I multiply this 3.406 by 10 to the power of 2, which is 100. Whenever I multiply a number by 100, the decimal point has to be moved 2 digits to the right. Here in 3.406, if I move the decimal point 2 digits to the right, I will get 340.6. So the antilogarithm of 2.5322 is equal to 340.6. Okay, let's look at the next example. Antilog of bar 3.5322. Okay, so to get antilogarithm of bar 3.5322, I consider only the digits after the decimal. So I get the number 5322. Already I got value for 5322 in anti-logarithm table, that is 3.406. The same can be taken here. Now this value should be multiplied by 10. For this 10, the digit we have here before the decimal should be taken as exponent. So this bar 3 is nothing but minus 3. So for 10, we'll have the exponent minus 3. And 10 to the power of minus 3 can be written as 3.406 divided by 10 to the power of plus 3. So 10 to the power of plus 3 is nothing but 1000. So 3.406 divided by 1000. Whenever I divide a number by 1000, the decimal point has to be moved 3 digits to the left because there are 3 zeros. So I need to move the decimal point 3 digits to the left, but there is only one digit on the left side of the decimal point, that is 3. I need 2 more digits. So I am adding 2 zeros before 3, that is 003406. Actually I have decimal point here. Because I divide by 1000, I need to move the decimal point 3 digits to the left. Then I will have decimal point here. So the anti-logarithm of bar 3.5322 is equal to 0.003406. Here we are going to see how to find anti-logarithm of a negative value, that is minus 2.4678. If I have negative sign in front of a value, it is applicable for all the digits in that value. That is, this minus is applicable for the integer part 2 and also for the fractional part 0.4678. When we want to use anti-logarithm table for a particular value, we will consider only the digits we have after the decimal point, and the sign of those digits must be positive, that is plus. But here in minus 2.4678, the sign of 4678 is minus. So we cannot use anti-logarithm table for 4678. What do we have to do? What we need to do in this case is we have to convert this minus 2.4678 as a value with bar. How? For that, we need to consider the integer which comes right after 2.4678. So the integer which comes right after 2.4678 is 3. So I have to subtract 3 from it. To adjust this subtraction, I have to add 3. In the next step, what I have to do is I have to take this minus 3 and plus 3 in front of minus 2.4678. Then I get minus 3 plus 3 minus 2.4678. Now I have to simplify this plus 3 and minus 2.4678. So the simplification of plus 3 and minus 2.4678 is plus 0.5322. Okay, now we have to write minus 3 and plus 0.5322 together. How? Bar 3.5322. So this bar is nothing but minus sign, and this is applicable. The minus is applicable only for this 3, and for this fractional part 0.5322 the sign is positive. Now we can use anti-logarithm table for this one, because we will consider only the digits after the decimal. So here we have the digits 5322 after the decimal, and the sign of this 5322 is plus. So minus 2.4678 is equal to bar 3.5322. So anti-logarithm of minus 2.4678 is equal to anti-log of bar 3.5322. Here, to get anti-logarithm for bar 3.5322, we consider only the digits after the decimal point, and the sign of the digits after the decimal point must be positive. Clearly here this fractional part is positive because we have negative sign only for 3. and already we got a value in anti-logarithm table for 5322, that is 3.406, and always it has to be multiplied by 10. For this 10 we have to take the digit before the decimal point as exponent. This is minus 3, so this minus 3 should be taken as exponent for this 10. Now 3.406, this 10 power minus 3 can be written in denominator as 10 power plus 3. So 10 power plus 3 is nothing but 1000. So whenever I divide a value by 1000, I need to move the decimal point 3 digits to the left. Already we have 1 digit here, we need 2 more digits. For that we can add 2 zeros. So finally we get 0.003406. So this is the anti-logarithm of minus 2.4678.